Okay, here are the rules of surds, just for your notes. The square root of a times the square root of b is the same as the square root of ab. Alright? Also, the square root of a divided by the square root of b can also be expressed as the square root of a divided by b. And finally, a times the square root of c plus or minus b times the square root of c will equal a plus or minus b square root of c. Alright, you can collect the constants together. Good. I want to show you an example of rationalising the surd. Okay, rationalising a surd. Alright, if you have a fraction with a surd on the bottom, then it needs to be removed. And we call this rationalising, or it needs to be rationalised. This is done by multiplying the top, the numerator, and the bottom, your denominator of the fraction, by the surd. Okay, so let's show you this. We've got, oh, hang on, do it in black. We've got 1 over square root of 3. So our denominator is a surd. To rationalise that, we must times through by that surd. Just like that, alright? Which will obviously give us the square root of 3 over 3. And you've rationalised it. Right? It's far simpler to solve or to work with. Fantastic. What you also need to be aware of, that if you have a sum that looks something like this, where it's a fraction, but the denominator is a surd and another constant, alright, we need to remove it just in the same way. However, we need to times it by something called the conjugate. Okay? Oh, sorry, the conjugate. Okay, let's split here. Conjugate. Alright. Which is the same as the denominator, but with the opposite sign. Okay? So it looks like this. We've got 1 over 1 minus the square root of 2. We must times that by the conjugate, which is 1 plus the square root of 2. And times both the numerator and the denominator by that. Alright? And you'll see that that results in the denominator being rationalised. It becomes a rational number. Alright? Negative 1 over negative 2. Fantastic. Okay? Well, I should get rid of that, really. There we are. So that's rationalising a surd. Remember, if you have a denominator that isn't just a surd on its own, it's a surd plus or minus something else, you must use the conjugate. I've just noticed a mistake in my notation here. Hang on. This should be a plus, not a times. It's just the way I've written it. It should be a plus. So as I was saying, if you have a denominator that has a surd plus a constant or minus a constant, the conjugate is exactly the same, but you change the sign. All right, so it's a minus here, it becomes a plus. You times through by the both. Okay, and that will rationalise the surd. Last example I want to show you is just to remind you how to simplify a surd. All right, just how to simplify a surd. So if I have 10 over the square root of 5, and I want to simplify it, first of all I have to rationalise it. Okay, so I will say times by the denominator, which in this case is the square root of 5. Well, that'll give me 10 times the square root of 5 divided by 5, which gives me 2. What have I done there? Sorry. Which, as you can see, will give you 2 root 5. Okay? If you have a surd that is large, like, let's say, square root of 45, okay, we can simplify that further. You have to look for factors of 45, factor pairs in fact, and you're actually looking for the smallest true square, which is a factor. And we know our square numbers are 1, 4, 9, 16, and onwards. Okay, we are looking for the smallest true square, so one of these numbers, which is also a factor of 45. So you should be able to see already in this case that we're looking at 9. 9 is in the 45 times table, and we know that 9 times by 5 is 45. And using our rule previously, which said that if any number square root of times by another number the square root of, we can join them together, a, b. Using that rule, we can say that 9 times 5 is this, root 9 times 5 is the same as root 45. Okay, so you should be able to see we can simplify that again, because we know the root of 9 is 3, and obviously the root of 5 stays in that form. Okay, so we've simplified root 45 down to 3 root 5. Alright, and that's the last of the examples. If you can try the question sheet attached, and that'll be due for next lesson. Thank you.